In this video, we are going to review inequalities and equations. We're starting with equations. I've written GMDOS up on the board because I wanted us to remember that we're working in reverse order of operations. We're working in reverse because we're trying to isolate the variable. So we're using reverse order of operations to determine which steps we get rid of first, which numbers to get rid of first. So we have the first problem here, 2 times the quantity x minus 4 equals 12. Now, this one's a little bit tough because normally we get rid of subtraction and addition first. However, this one's inside grouping symbols. And when we're working in reverse order of operations, grouping symbols are last. So we're going to get rid of the 2 first. And the way I get rid of the 2 that's being multiplied by that difference is I divide by 2. And that helps me cancel it out. What I do to one side, I do to the other. And I'm left with 12 divided by 2 is 6. I'm going to bring down the equal sign, and I'm going to bring down x minus 4. I'm allowed to get rid of parentheses because they were just there to let me know that the 2 was being multiplied by that difference. Okay, now we have an x minus 4 equals 6. So we're going to get rid of 4 by adding 4. That helps it cancel out. What we do to one side, we do to the other, and we're left with x equals 10. It is so important to take this x and plug it back in. We're going to take this 10 actually and plug it back in for x. So we have 2 times the quantity 10 minus 4, and we're saying that that is equal to 12. Well, let's see. 10 minus 4 is 6, and 2 times 6 is 12, so that works. So it's important that we plug it back in just to check it. Okay, let's look at this last one here. Reverse order of operations. So I would start with addition and subtraction first. I'm going to get rid of the positive 15 by subtracting it, and that cancels. What we do to one side, we do to the other. 20 minus 15 is 5. Bring down your equal sign, bring down the 1/5 times x. Now I'm going to get rid of the 1/5 that's being multiplied by x, and I do that by dividing by 1/5. That cancels. What I do to one side, I do to the other. The steps for dividing fractions are keep, change, flip. And when I multiply these straight across, I get 25. So we have x equals 25. I'm going to plug this 25 in where I see x. I'll rewrite it over here, 1/5 times 25 plus 15 should equal 20 if I've done everything correctly. Okay, multiplication comes first. 1/5 times 25 is 5. I'm going to add 15 to that, and I do get 20, so that works. Let's look at some inequality problems. Actually, an inequality problem. We're going to solve this problem, and then we're going to graph the solutions. So I'm going to draw my wall. Again, reverse order of operations. Normally, we would get rid of addition and subtraction first. But if we look at a similar problem, let's see, 2 plus 4 divided by 3. If we were just using order of operations to solve this problem, we would do the 2 plus 4 first, and we would get 6 divided by 3. So because we did the numerator first, we're doing reverse order of operations when we're solving equations. We're going to get rid of the denominator first. We're getting rid of divided by 3 by timesing by 3, and that cancels. What we do to one side, we do to the other. I'm left with 5 plus x is greater than or equal to negative 12. Okay, now I'm getting rid of the positive 5 by subtracting it. That cancels. What I do to one side, I do to the other, and I'm left with x is greater than or equal to. So here I have a negative 12 minus 5. I'm going to add the opposite to see that I have 2 negative signs. A negative 12 plus negative 5 is negative 17. So now that the variable is isolated, now I can graph it. I'm going to put 17, a negative 17 on the number line. The number before negative 17 is negative 18, and after it is negative 16. So I'm putting 3 numbers on the number line. I'm going to think about some possible solutions. So if x is greater than or equal to negative 17, x could be 5, or it could be 0. So I'm going to use a closed dot to demonstrate that 17 is included in possible solutions. And I'm going to head in the direction of the 0 and the 5 and all those numbers that are greater than or equal to 17.